10 to noon, right?
I'll be here, yeah, we'll be here 10 to noon each day, Monday through Thursday.
Okay.
Horribly deformed spinal column.
Okay. And then I have, on Wednesday, I have bio dropping, which usually is bio dropping,
That's kind of key and vital.
from 12 to 2, where you can come ask me.
You know, for a gross drawing, that's actually good. Central Canal.
Yeah, I'll be around here.
Okay, cool. Thanks, I appreciate it.
Alright, so you have your posterior sulcus, your anterior fissure, right? So we know this is the front of the body.
Doing the half reaction first, and then
Now let's start talking about what's actually happening in this guy.
Okay.
let me do that. You wouldn't?
Let's say, for example, some evil jackal stabs you in the arm. Okay? You have a couple of sensory neurons out here that are going to feel that. It's going to hurt, and they're not going to be happy. These are your receptors. Your receptors are going to send a signal in through your spinal nerve all together, and they're going to come together and send a single signal off of this sensory neuron. It's going to come off and come into your dorsal horns. This is your sensory pathway in your reflex arc. Everyone got that? Now, whenever you have neurons, whenever you have synapses, you're going to have a larger bulge because an axon is really thin and a neuron body is really thick. So it's going to be a bulge. So this area right here is going to produce a bulge. That is our dorsal root ganglia. Starting to come together? Okay. And you're going to have nerve coming off and nerve coming off. Now.
So where the signal all comes together is your dorsal ganglia.
Exactly.
Ganglia.
All your signals coming together, sending one consolidated sensory signal into your dorsal horns.
So it's just the sensory part goes to the very back?
The Senate, they all endorse one bill and put it through rather than
Exactly. Exactly.
all
Rather than
million
all
different.
sending a whole bunch of different bills. They all get together and they get their goals all on this one bill. And they'll send that through. And it's a lot easier to delegate that bill than it is
A million
1,000 different issues.
So all the sensory parts are on the back, on the dorsal side
Yeah.
of the gray matter?
Dorsal is sensory.
Okay.
Ventral is motor. Dorsal is sensory.
Got it. Okay. Is there like a few other layers, like something in between, or is it just
No, not
two? No? Okay.
Sensory and motor. It's all
Sensory
divided
and motor.
into that.
Okay.
We're going to go into sympathetic and parasympathetic stimulation, and it's all going to add to this picture. But ultimately, it's still sensory and motor.
Got it. Okay, that makes sense.
So we have our sensory coming in here, right? Now, in here, we're going to have our internal. Remember that? We stated earlier where you have stimulus,
once in your shoe.
integrating center, and response. Remember that?
Most semesters with me.
So is that your integrating center?
This is our integrating center, our spinal cord. Your spinal cord is capable of making decisions on its own, separate from the brain. And that's what it does in a spinal reflex arc. So this neuron right here, so you have a sensory neuron and an interneuron. The interneuron is going to make the decision that, well, somebody has stabbed us in the arm, we better get our arm out of there. We need to move our arm. So this is going to make the decision to move the arm. It's going to send that signal to a motor neuron.
Because at the same time, there's another signal going to the brain so that we register it, like you said
There
before.
is. There is. So here we have our motor neuron, and our motor neuron is going to send his signal through his axon out through the ventral rootlets, which comes together in the ventral root. It has no reason to synapse with anything, so he's not going to clog this already packed ganglia. He's going to just go outside of it.
Because he's just sending a message, he's not one message,
Right.
he's not receiving.
Exactly. But once we get past that ganglia, is there any reason why it has to be a separate nerve?
so that he can go to the center.
We were working with silver nectar.
And he's going to affect, say, a muscle.
He was telling us a story where
But is there any reason for him to be a separate nerve at this point?
Because it needs to do, it's not sensory, it's motor command. It needs to go to the motor part.
So?
It needs to be separate,
Why?
right?
Why?
To give off an action.
The only reason we're separate from this guy is because we don't want to get in the way of all those synapses.
Oh,
We don't want
okay.
to confuse it. So you're going to have your dorsal root, which is alongside, and then they come together into a single spinal nerve.
Like a
Oh, wow.
when you've got 3 lanes of traffic on each side, they put a huge divider in the middle. But then once there's less traffic, it goes down to 2 lanes with no divider.
Right. If you're separating out to go into this freeway interchange with all these neurons and synapses, or you have a lot of on-ramps or whatever, you're going to be divided from the rest. Like in a city. If you're in a city, you have a lot of intersections, so they're divided. But once you leave the city and you're onto country roads, half the time they don't have dividers at all in between. It's just one road.
It's the 6-lane highway versus the 2-lane.
Exactly. So this is your 6-lane highway, and this is outside the city. We've switched to a 2-lane road. Makes sense?
Yep.
It's more efficient for production and building our body that way.
Got it. I thought they needed to be separate.
Nope, they don't need to be separate. It all comes together into one spinal nerve. So you have your dorsal ganglia, and you have your ventral root, but it's not a ganglia, it's a nerve. So you have your ventral root, and you have your dorsal root, and your dorsal root ganglia, and they separate out into the rootlets that go to the ventral rootlets and the dorsal rootlets.
And then once you reach the arm or whatever, they start to separate out again into the separate nerves, the separate muscles.
Right. Yes. They'll branch out down those routes. But for the time being, it's all one spinal nerve. So, there you go. That is your spinal reflex arc. Everyone got that so far? Okay. Now we're going to add to this picture. But we're done with this. We're done with the reflex arc. That's all it is.
Okay.
However, we also have to consider our paravertebral ganglia.
And then do I have to balance prior? I don't think we do. No, you don't. You couldn't. So I can cancel that one of those.
There.
Okay, this severely annoys me that in this entire lecture, that was the stuff that was throwing me off, and it's because you didn't label that. I was like, what the heck is this extra thing? Thinking that it's something else.
Well, maybe this will clarify it then.
Yeah.
So you have your paravertebral ganglia. This is also called the sympathetic chain ganglia.
Okay.
So you can call it paravertebral, you can call it sympathetic chain. Either one, they're both correct.
How is it going to be on the test? Either one?
It can be either one.
Okay.
It's called both. Equally.
Paravertebral.
Paravertebral describes the location. It's kind of beside the vertebrae. I mean, these guys, this is coming out through the intervertebral foramen between 2 different vertebrae. So they're coming out the sides. Whereas this guy is on the side of the whole scenario. He's going up and down along the spine. Before we start talking about pathways in this guy, let's go back to the sympathetic stimulation. What is the function of a sympathetic stimulation?
Fight or flight.
Fight or flight, right? It's an emergency situation response. So it's got to be fast.
Yeah.
It's got to hit the entire body all at once, right? The way to do that is with these guys.
Oh.
So we have a motor response that we need to do sympathetic.
Yeah, because they actually are blessed with a gift.
This motor neuron here is going to send a signal along the same pathway, except here he's going to veer off, and he's going to synapse it up. Lateral horn.
Oh, so that affects all the rest of the body for all the other actions that need to be made.
Yeah, this is going to put our body into sympathetic mode. It's not controlling our muscles, but it's controlling our visceral organs and our smooth muscle.